Oke, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi wabarakatuh.
Okay, good evening, class. For today, we are going to discuss about the linear equation of two variable system. But before we are going to discuss about the material today, let me check your attendance. Is there anyone who sent today?
No, sir.
Okay, thank you. Okay, in here, we are going to discuss about the linear equation of two variable system. But before that, I'm gonna tell you about the indicator of competent achievement. Okay, so this is several indicator, but for today we are just focus on the point 1 and 2. So the learning objective for today is identifying the linear equation of two variable, and then distinguish two variable linear equation BLTV and solve with the variable linear equation system. Okay, for the apperception, did you remember about the one variable system, one variable equation system in here?
Yes, sir.
Okay, maybe Hanifa can explain it. How can we get the x value in here?
Okay, sir. So this is the first variable equation. We have 3x plus 9 is equal to 24. And then we move the 9 in left side to the right side and become the negative number, and we get the result x is equal to 5.
Okay, good. So this is the appreciation material for our material today. That is one variable in here, that is x, one variable equation system. So we have to solve by algebraic structure in here. So we have x is equal to 5. And then what about this one? Anyone else again want to know and want to answer it? No one? Maybe Yusuf Putra.
Right, sir. So we have the equation 5p is equal to minus 5p plus 10. And then the next step is we the minus 5p switch place to the left side, and then it become plus 5p. And then we get 5p plus 5p is equal to 10p is equal to 10. So by dividing all of the side by 10, we get p is equal to 1.
Okay, thank you. So this is also the one variable. In the previous we have x, but in here we have p. So the variable can be determined and can be have an value any alphabet in here, not just x. So based on the use of explanation, we have p is 1, which algebraic structure in here. And then before we start about the linear equation, I want to show you the video about the system of linear equation in here for the application in a real life.
Sorry, sir, but we don't hear the sound of the video.
Thank you.
Simultaneously graphed. Hello, I'm Professor Von Schmohawk, and welcome to YU. So far, we have seen several types of geometric relationships that can exist when two linear equations are simultaneously graphed. Simultaneously graphing systems of equations like this is often a helpful tool in analyzing physical and mathematical relationships. In particular, the points of intersection of two graphs have a special significance, since the intersection points represent common solutions to both equations. To illustrate this concept, let's look at a race between a tortoise and a hare. As the race begins, the hare, engrossed in a fascinating chapter in his algebra book, decides to give the tortoise a head start so that he can finish reading the chapter on solving systems of linear equations. As the race begins, the tortoise starts down the road at 1/2 mile per hour, a very brisk pace for a tortoise. We can graph the tortoise's distance from the starting point as a function of time, letting the vertical axis represent distance and the horizontal axis represent elapsed time. We see that in the beginning, when the elapsed time is 0, the tortoise's distance from the starting point is also 0. After that, since he is traveling at a constant speed, his distance increases linearly as a function of time. Since the tortoise's speed is 1/2 mile per hour, after 4 hours, he has traveled 2 miles. 4 hours after the race has begun, the hare finally finishes his algebra chapter. Even though the tortoise has obtained a significant head start, the confident hare decides to take it easy. Since he knows that even casually strolling at 2 miles per hour, he will eventually pass the tortoise. So 4 hours after the race has begun, the hare is still 0 miles from the starting line. But from this point on, he travels at a constant speed of 2 miles per hour. Since the hare travels at a faster rate than the tortoise, the hare's graph has a greater slope. Looking at these two graphs, we see that throughout the race, the tortoise's distance increases linearly with time. And after 4 hours of elapsed time, the hare's distance also increases linearly. Until at some point, between 5 and 6 hours after the race has begun, the hare and tortoise meet. The point where the two graphs intersect represents the instant at which the tortoise and the hare are at the same place at the same time. If we can create equations for these two graphs, there are mathematical techniques which we can use to determine the coordinates of the point where the two graphs intersect. Knowing these coordinates, we can then determine the exact time and place where the tortoise and the hare meet. To create an equation for the tortoise's distance as a function of time, let's use the variable x to represent the time coordinate and y to represent the distance coordinate. We saw in the chapter on solving motion problems with linear equations that if we graph distance as a function of time for an object traveling at a constant speed, the slope of the graph will be equal to the speed of the object. So the slope of this line is 1/2. Since we know that this graph intercepts the y-axis at the origin, we can use the slope-intercept form to write the equation for this line. The value of the constant m in this equation is the slope of the line 1/2. And the value of b is the y-intercept 0. Eliminating the 0, we see that the equation for this line is y equals 1/2 x. Now that we have the equation for the tortoise's graph, we need to derive the equation for the hare. Since the hare is traveling at a constant speed of 2 miles per hour, the slope of his graph is 2. We don't know the line's y-intercept, but we do know that the line passes through the point 4, 0. So we can use the point-slope form to write the equation for this line. Filling in the values for the constants, we replace x1 in the equation with 4, y1 with 0, and m with a line slope 2. We can then simplify the equation by eliminating the 0 and distribute the 2 to the terms in parentheses. Multiplying 2 times 4 to get 8, we see that the equation for this line is y equals 2x minus 8. We now have equations for the tortoises and hares' distances as functions of time. It is important to remember that although the lines described by these equations extend infinitely in both directions, only the portion of the lines whose coordinates are positive are meaningful in this particular example. If we can now use these equations to calculate the coordinates of the point where the two graphs intersect, we will be able to determine the exact time and distance where the tortoise and the hare meet. In the next lecture, we will introduce a technique called substitution, which will allow us to calculate the unique coordinates which simultaneously solve both equations and thus find the intersection point of the two graphs.
Okay, for this video in here,
Coordinates of the
we have some example in the real life, if there are any race in here, but in this video it's about the tortoise and the hare. So in this story, we know that the tortoise start first to do the race, but the hare do the race 4 hours later after the tortoise. So if we do in the graph, or we draw in the graph, we know that we have some graph in here about the tortoise and the hare.
point where the two
And
graphs
with
time, graph distance,
any calculation
line.
in here, for linear equation in here, this y is equal to mx plus b. And then we have the equation for the tortoise and the hare in here. So different with the the previous material that we have an appreciation with one variable, we have two variable in here, y and x. In the previous, we just have x, p, or something else in there. There is only one variable. But in here, we have two variable in here. And then if we do the graph in here, and then we have an intersection between the two equation in here about the hare and the tortoise, the intersection in here is called to be the solution of this linear equation system of two variable actually in here. And then if we want to know what is the intersection between them, in this video, we know that the solving system of equation by substitution. So this is about the application or the real example of the linear equation of two variable. For today, we are going to discuss about it. But first, we are going to explain first or step by step. So what is a linear equation of two variable? Linear equation of two variable, this equation of two variable or PLTV is something equality which have the variable and respectively variable rank 1. So this is the rank, the general form of PLTV. Ax plus by plus c is equal to 0, or ex plus by is equal to c, which is the a, the x, the y is called to be the variable in here, and then the a and the p is called to be coefficient in here. Then the equality linear two variable. Maybe some of you guys can give explanation in here, which is the variable and then coefficient. Mean? Okay, for number 1, maybe the coefficient and then variable for the linear equation of two variable. Okay, Yasmin, are you still there? If there's no Yasmin, maybe Yusuf. Yusuf? Okay, if there is no one want to answer, maybe I'm gonna explain it first. So this is the first one is 3x plus 6y equal 12. So from the general form of the PLTV or the linear equation of the variable ax plus by plus c or equal 0 or ax plus by equals c, we know that is called to be variable in here, the x and y, and then this is the coefficient 3 and 6, and then this for the c in here. And for the number 2, does anyone want to answer which one is variable, constant, and c?
I want to try to answer, sir.
Yes.
Okay. The variable is P and Q. And 30 is the constant. So this is same with the general form AX plus BY plus C equals 0.
Okay. What about the 5 and minus 3 in here?
Five and minus 3 is the coefficient.
Okay, thank you. Any other for number 3 maybe and number 4?
Excuse me, sir. I want to.
Yes, Yasmin.
For number 3, the variable is m and n, and for the coefficient is 2, and for the constant is -8. And for number 4, the coefficient is 1/2 and 3/4, and the variable is x and y, and the constant is 6.
Okay, that's correct. Thank you. So this is a several example for linear equation of two variable. And then if we have PLTV or the linear equation of two variable, not the system. In PLTV in Indonesia is persamaan linear dua variable. We want to know the variable in here. We have to know the graph in here. Suppose we have 3x plus 6y equal 12. There is a graph in here. You have to do the graph. You can do it in the GeoGebra maybe. We have to determine when the y is 0 and the x is 0. And the x and if the y is 0, it's automatically x equal to 4. 4, 0, which is 0 and 3x equal 12. So x is 4, x equal 0 and 6y equal 12. That is 0,2. So 4, 0 and 0,2. If we have two point in here, we can draw a line in here. You can do it in the GeoGebra or manual. So the next is linear equation of two variable system. It's different like previous. We have system in here, which is we have two linear equation of two variable, which is we have to know the intersection of them. And then If we want to determine the solution, suppose we have 2x plus y equal 5 and x plus y equal 4. We have several method in here, that is substitution, elimination, and the graph method. But in here we have substitution methods only. So what is substitution method? Determine the solution of this linear equation of the variable, and we have x plus y equal 4, and then become the y equal to 4 minus x, and then we substitute y in here because the value is equal to 4 minus x in here, so become 2x plus y equal 5, then 2x plus 4 minus x equal 5. So by some algebra structure and calculation, we have x plus 4 equal 5 and x1. Then even to know the y, because we have two variables in here, that is the intersection of the line become the point. X plus y equal 4, we have x equal 1, and then 1 plus y equal 4, that is the y equal 3. So the intersection or the solution is 1,3. Okay, I already have given you the LKPD or the work submission in the G class. Maybe you can discuss it with your friend, and then do presentation in here. I will divide you in the several groups. Okay, is there anyone already finished the answer?
Yes, sir, I already finished it.
Okay, I'm gonna stop share. Maybe you can share screen your presentation.
Wait a minute. Okay, good morning, good evening, everyone. Here I will present result of the discussion. So we have the problem here, the solution set of the system of equation 3x plus y equal to 18 and 2x plus 3y is equal to 26. For the solution, first we change 3x plus y equal to 18 into y equation. So we have y equal to 18 minus 3x. Then with substitution method, we obtain 2x plus 54 minus 9x is equal to 26. And after some calculation, we get that x is equal 4. After that, we substitute it back into 3x plus y equal to 18. We obtain that y is equal to 6. So the solution is x equal to 4 and y equal to 6.
Okay, maybe if we want to do in the point, what the form of x and y? If we want f x1 and y3 is 1,3, and then the answer is?
I'm sorry, sir?
If we have the solution is x is equal to 1 and then y is equal 3, we have 1,3, that's the point. So for the solution, what is it? What the point is it? The point of the solution.
4,6, sir.
Okay, thank you. Okay, thank you. That's all for today. Maybe Yasmin can stop share. For the next meeting, we are going to discuss about the next method, that is the substitution method. And then don't forget to do your assignment. And then maybe anyone else want to conclude what have we learned today? Okay, no one. Okay, maybe I'm gonna tell it what we have learned today. Today we have learned about the system of linear equation of two variable, and then linear equation of two variable, and then the method of substitution. So for the next meeting, we are going to do the method of elimination and then the graph. So that's all. Any question before we are close our meeting today? Okay. If there is no one, thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.